So parallax is the apparent shift in the position of an object with respect to another when we shift our eye sidewise. Now from the simple trigonometry we know that angle is equal to arc upon radius. So from this formula and the diagram we made, we get theta is equal to b upon s. Now by knowing the value of theta and any of the quantity b and s, we can find the remaining one. Okay, now we have three quantities. Theta is equal to b upon s, that is angle is equal to arc upon radius. So if we know theta and b, we can find s, and if we know theta and s, we can find b. So this is the principle that we use while applying parallax method. So this method is actually used under the condition when b is lesser than s, or I should say this distance that we are trying to calculate or the object that we are observing is at a far distance. Only then we can apply this method, because in that case the orders are same and we are doing approximate calculations, not the exact ones. Okay, so theta is equal to b upon s, and the condition is the distance we are taking between the observation points is much lesser in comparison to the distance s, or we should say our object O is placed or is at a distance much farther in comparison to the B. Okay, now let's see how we can apply this method to find the distance of moon or any other planet from earth. Okay, so we are going to apply parallax method. So now we are going to find the distance of moon or any other planet, let it be capital P, from earth's surface. Now to find this distance, we take two observatories at different positions on the earth. So let these observatories at point A, this, and at point B, right, the distance between these two observatories, let this distance AB is equal to small b, but this distance is large. Okay, the two observatories are separated by a large distance, and by large distance we mean that when we are at A we can't see B directly, or when we are at B we can't see A directly. That means if there is someone at point A who is observing this planet or moon from point A like this, and there is some other person who is simultaneously observing this planet at a point B, let this be point B, then in that, during that process, the person at A and the person at B can't observe each other. So the distance between A and B should be large, and this observation is taken simultaneously. These two observations, like observing the planet P from A and observing the planet P from B, is taken simultaneously, and these 2 points are at a large distance, A, B, represented by B. Now we want to know the angle, this angle made by A and B, like this angle, or we call it as parallactic angle or parallax angle theta. We want to find this angle, but if we can't see B while observing, then we have only single line, right? We have this much information. The person who is seeing the planet from A, he only has this line, and for angle, to measuring any angle we need at least two lines. So for this we need some reference line, from that we want to measure angle. Means to measure this angle we want a reference line, because these points are at a large distance apart and they can't observe each other. So if I am at A, I have only this line, there is no other reference line to measure the angle, while when someone is at B, then that person has only this line. Okay, so this is the difference. Now we have we need some reference. For reference we take a star which is much farther from the earth and the planet P. Now if we take a star which is very much farther from Earth and the observing planet P, then the light rays coming from that particular star comes parallel, right, comes parallel to each other towards the Earth's surface. So suppose I have a star S dash somewhere here at a very far distance. Okay, I have a star S dash somewhere at a very far distance from Earth as well as from the planet P. Then the rays coming from it will be like this. The rays that are coming from a farther star S dash will be like this, parallel rays. Okay, now these rays that are coming from the star S dash, these all are coming from star S dash, which is very far from Earth. These falls on the point of observation, that is A and B, and let the angles made by them are these phi 1 and phi 2. So the angle made by these rays are phi 1 and phi 2. All right. Now by applying simple mathematics, if we take a normal here, this will be parallel to these lines, and the angle made by this normal divide this parallactic angle into two parts, and it will be equal to phi 1, this is phi 1 and this is phi 2, like this. Okay, alternate angles between the parallel lines. So now we split the parallactic angle theta into phi 1 and phi 2, and we can observe these angles phi 1 and phi 2 from here, because we have two lines here and we can see how the formation of angle phi 1 and phi 2 takes place. So we can find phi 1 and phi 2 and then we can add them to find the parallactic angle. Okay, so now we have angle PAS dash. I am considering it as S dash because these both rays are coming from S dash. So angle PAS dash will be phi 1 and angle PBS dash will be phi 2, and angle APB is equal to theta is equal to phi 1 plus phi 2. This is what we observe from the diagram. Okay, now since B is lesser than S, so we can take AB as an arc of length B. The distance B, like this is the distance B between A and B, so we can consider it as an arc of length small b. So AB is equal to B, which is lesser than S. Now applying the formula, angle is equal to arc upon radius, that is theta is equal to B upon S. We can find capital S by using S is equal to B upon theta. Now capital S is this distance that we need to find, that is the required distance, the distance of planet P from Earth's surface, that is the distance S, can be calculated by using the formula B upon theta. Theta can be calculated by phi 1 plus phi 2, and B is the arc on the Earth's surface that can be measured. Okay, now this is the process how we apply the method of parallax to find the distance of a planet from Earth's surface. So this is the parallax method to find distances indirectly or to measure length indirectly. We can also find the diameter of moon or any other planet by using this method. Let's see how that works. So to find the diameter of moon or any other planet from some point on the Earth's surface, like we are observing moon, suppose this is the moon or any other planet whose diameter we want to calculate from Earth's surface, and we are observing it from point O. Okay, so what we did, we are observing moon or any other planet P whose diameter we need to calculate or find from Earth's surface. So let this is the diameter AB. Then what we do, we observe the moon by using a telescope and place it once towards A and next towards B. Alright, then the two positions of telescope gives us the angle theta. Now, this is the angle theta, and the distance from moon to earth is capital S, and the diameter that we have to find is capital D. This AB is capital D. So by knowing the angle AOB, we can find the diameter of the moon. Let's see how it works. We know the formula, angle is equal to arc upon radius. So here angle is theta, right? Arc is AB, that is capital D, and radius is capital S. So we want to find D, that will be S theta. Now S can be measured by some other methods using time, technique and all. So if we know the distance S and we find angle theta, by knowing these two quantities we can find diameter capital D of moon or any other planet, right? So the process is by knowing S and theta, D can be determined by using parallax method. So this is the parallax method that we use to find length indirectly, or it is basically used for larger distances that we can't measure directly by some instrument. Now the next method that we have is the reflection or echo method. As the name suggests, echo, here we are going to use sound waves, and this is the method which is basically used to find the distance of a hill. So for that we fire a gun towards the hill, and we observe the time interval between the instant of firing of the gun and the instant of hearing the echo of the gunshot. Okay, so what we are going to do, हम एक हिल का डिस्टेंस मेजर कर रहे हैं टू मेजर distance of hill, and for this we shot a gun. That means we are going to fire a gun and will note the time between instant of firing and hearing the echo of the gun. Now if we imagine this, we can conclude that this is the time interval in which sound first travel towards the hill and then come back from the hill, right? So sound जितना डिस्टेंस हमें चाहिए, साउंड उसका डबल ट्रैवल कर रहा है. एक बार वो जा रहा है हिल तक एंड देन वापस आ रहा है towards our position so that we can hear that echo. So the total distance जो इतना टाइम हमने ऑब्जर्व किया उसमें ट्रैवल हुआ, it will be twice of the distance of hill. Let the time taken is small t. Okay, the time taken is small t, and v is the speed of sound that we know, that is the sound wave is traveling with the speed of v. So if we observe time equals to t, and we know that speed of sound is small v, and the distance traveled by that sound wave is twice of the distance of hill, because first it go towards the hill and then come back as echo towards our position. So the total distance traveled is 2s. So from basic formula, distance is equal to speed into time, we get 2s is equal to v into t, or we can find s by using this formula. S is equal to v into t upon 2, and this is the reflection or echo method, where we use the technique of reflection or echo to measure the distance of a hill. But this method is not convenient if we want to find the distance of moon or some farther object, because sound wave can't travel till that position. So for that we have separate methods like laser, radar and sonar method. So let's talk about the laser method, how it works. Actually laser method is similar to the reflection method only, but the difference is it works for farther objects, right? So what is laser method? The first of all, the word laser, laser stands for light amplification by stimulated emission, stimulated emission of radiation. So this is the full form of laser. But the main thing that we have to study कि laser की property क्या है. So laser is a source which is very intense, highly monochromatic and highly directional, right? Laser बहुत ज़्यादा intense है, monochromatic है and directional beam है, so that it can go to the larger distances without disturbing. So when we can send a laser beam towards the moon, and its reflected pulse can be received by us. So the process is, we are, instead of sound waves, as we use sound waves in reflection method, now we are going to use laser beam, and we send that beam towards the moon or the farther object, and its reflected pulse is received by us. Similarly, the distance traveled by that beam, by that laser beam, is twice the required distance. We only need the distance from earth to moon, right? But laser beam is traveling to moon and then coming back. So one is for going and one is for coming back. So actually the time that we will observe is for twice of s. Suppose the time observed is t and the speed of laser is always c, that is the speed of light. C is equal to 3 into 10 to the power 8 meter per second. So by knowing the speed and the time, by observing the time, we can find the value s. So what we are doing, we take a laser beam, send it towards the moon and observe its reflected pulse and record the time that elapsed between the instant the laser beam is sent and the beam is received back. So we are observing the time t that elapsed means that is consumed, that elapsed between the instant of sending laser beam and receiving it back. So we are going to observe that time, and we know that laser is a kind of light, so its speed will be the speed of light 3 into 10 to the power 8 meter per second always, and the distance that it is covering is twice of s. So by the formula we have distance is equal to speed into time, and we can find s as s is equal to c into t over 2, where c is the speed of light, that is 3 into 10 to the power 8 meter per second. Okay, the same thing is for radar method. The only difference is that there we are using radio waves. Okay, let's see what is the radar. So radar stands for radio detection and ranging. Radar stands for radio detection and ranging, and it can be used to measure accurately the distance of nearby planets. Okay, comparatively nearby planets के लिए हम इसको use करते हैं to measure the distance of nearby planets, and here we are going to use radio waves. Radio waves are used. Similarly, we send the radio waves from a transmitter and then which after reflection from the planet are detected by the receiver. So in this process of radar we have two devices. One is transmitter and the other is receiver, and here is the planet. So we send it towards the planet from transmitter and it come back towards the receiver. So again the distance traveled by the wave is the double, twice of s, or double of the required distance, and we measure the time, or we observe time t in which this whole process take place, and the speed of radio wave is again c, that is 3 into 10 to the power 8 meter per second. Okay, so the formula again becomes 2s is equal to c into t, that means we get s is equal to c into t by 2. So the formula remains same in case of radar, only the wave is changed, and by changing the wave we mean now we are considering some nearby planets. If we have planets farther, then we have to use laser. If we have some nearby planets, we can use radar, or sometimes this method can also be used to determine the distance of an aeroplane. Okay, this is also used in aircrafts to find their location or distance from some other aircraft or place. One more method is there in which we are using sound waves, that is sonar method. Now sonar stands for sound navigation and ranging. Let's see what is sonar method. Sonar stands for sound navigation and ranging. Now it is different from the normal reflection method, because sound waves in both cases, in reflection or echo method and in sonar method, in both cases we are using sound waves, but there in echo method we were using the normal sound waves, but here in sonar or sound navigation and ranging we are going to use ultrasonic waves. That is the difference. So in sonar method we are going to use ultrasonic waves which have frequencies greater than 20,000 hertz. Okay, so these are the waves that we are going to use in sonar method, and these are generally used for locating the position of submarines or some submerged rocks inside the ocean. So these are basically used when we are trying to find the location of something inside the ocean, as these waves can transmit through the ocean, right? So the waves, these ultrasonic waves can transmit through ocean, so that's why these are used in locating submarines or by the or in locating some submerged rocks. As submarines and these submerged rocks are capable to reflect these ultrasonic sound waves, so this method is used. The process is similar. We transmit these waves to a particular rock where these waves hit and come back to the observation point. The distance traveled is actually the twice of the distance required. All right, one to reach the observation point and another to come back. Okay, so the total distance traveled is 2s, and the total time that we observe that this sound wave take to complete the process is small t, and the speed of this wave in sonar method is small v. Okay, let this speed is v. So v is the speed of ultrasonic waves in water. This v is the speed of ultrasonic waves in water, and for this, now concluding this, we have the formula 2s is equal to v into t, and from this formula we get S is equal to V into T by 2, where T is the time taken by the ultrasonic wave to hit the target and come back. Okay, S is the distance that we need, and T is the time, and V is the speed of ultrasonic waves in water. So this is the sonar method. And the last method to measure large distances indirectly. Now we have to see how we can find small distances by indirect methods, and for this we have the method using Avogadro's hypothesis. So the method that we are going to study is an indirect method to find small distances, and the method is by taking the help of Avogadro's hypothesis. For this, first we have to know what is Avogadro's hypothesis. So according to this hypothesis, the actual volume occupied by the atoms in 1 gram of a substance is actually 2/3 of the volume of 1 gram of the substance. Okay, so Avogadro's hypothesis states that actual volume occupied by the atoms in 1 gram of a substance is 2/3. Okay, that 1 gram of a substance is 2/3 of volume of 1 gram of that substance. So substance के 1 ग्राम का जितना वॉल्यूम होगा उसका 2/3 ही एक्चुअल वॉल्यूम होता है that atoms occupied. Okay, so we use this technique to find small distances, and here the example we are taking is of atomic radius. So by using Avogadro's hypothesis we are going to find atomic radius or radius of an atom. Okay, so we are considering that we have a molecular mass of a substance, let that mass be capital M. So we are assuming that we have capital M molecular mass of a substance. Then this means that m grams of the substance will contain n number of atoms. N number of atoms means Avogadro number of atoms. If molecular mass of substance is capital M, then it means that m grams is equivalent to, or it contains capital N, that means Avogadro's number, capital N atoms in it. Okay, so this is the meaning of molecular mass of a substance. That means 1 gram will contain, since m gram contain n atoms, so 1 gram will contains n upon m number of atoms. Now if r is the radius of each atom, let r be the radius of each atom, then volume of each atom will be 4/3 pi r cube. Okay, 4/3 pi r cube, and volume of n upon m atoms is equal to n upon m into 4/3 pi r cube, or we can also write it as volume of 1 gram of that substance, because 1 gram contains this much atom. So volume of 1 gram is equal to n upon m 4/3 pi r cube. So this is the volume of 1 gram. Now let capital V be the actual volume occupied by the molecules of 1 gram of that substance. Then according to the hypothesis, so I am considering that capital V is the volume, we should say capital V is the volume or the actual volume Then according to Avogadro's hypothesis, the 2 by 3rd of this actual volume is equal to the volume occupied by the atoms. So according to Avogadro's hypothesis, the volume occupied by the atoms, that is n upon m 4 upon 3 pi r cube, is equal to the number 2 by 3rd of the volume capital V, and we know that this capital V is equal to, कैपिटल V को हम लिख सकते हैं by using the formula of density. We know that the formula for density is rho is equal to mass upon volume, right? And we are taking mass 1 gram, volume V. So we can write rho is equal to 1 upon V, or V is equal to 1 upon rho. Then according to this equation, we get n upon m 4 upon 3 pi r cube is equal to 2 by 3 rho, or we can rearrange it to find the value of r, that is small r is equal to m upon 2 pi n rho whole power 1 by 3, that is the cube root. So this is the atomic radius that we were trying to find using Avogadro's hypothesis. So the radius of an atom of the substance can be determined by using this formula, and to find this formula we use Avogadro's hypothesis method. Okay, so this was the method to find small distances using indirect method. That's it for the video. For further videos, stay tuned and keep studying. Thank you.